All right, strap yourselves in, because today we're going deep on something pretty wild, building a Linux system from scratch.
From scratch.
Yeah,
Yeah, I know what you mean. It kind of sounds like something, you know, only hardcore hackers would even try. But
right. In some dark basement somewhere.
exactly.
Yeah.
But this deep dive, you'll see, is going to break it all down. And even if you don't dream in code,
Yeah, and
you'll be able to follow along.
we're not trying to, like, instantly turn you into a Linux master or anything,
Yeah.
right? You'll definitely be able to hold a conversation about it after this.
Yeah.
Maybe even show off a little at your next tech get-together.
Right.
And honestly, some of this stuff is just fascinating in its own right.
Absolutely.
I mean, I had no idea. There are whole debates about whether 64-bit systems are always the way to go.
Well, and that's just the start. We're also going to dig into this thing called a macro processor, which I got to admit sounded like something out of Star Trek to me at first.
Yeah.
But it turned out it's a crucial tool in the whole build process.
Okay, so the source material we're using here is a guide. It's called Linux from Scratch,
Right.
version 9.0, or LFS, if you want to sound cool.
I feel like this.
But before we get too far, it's worth pointing out that this guide seems to expect us to already know a bit about Unix system administration.
Right. Well, that's because building an LFS system, it's not like installing, I don't know, an app on your phone or something.
That's right.
It's hands-on, very interactive. You're actually running commands, looking at what comes back, making choices along the way. It's more like if you think about building a house
Yeah.
from actual blueprints as opposed to just assembling like a pre-made kit.
So not exactly for someone who's completely brand new to Linux then.
Well, the guide does have a helpful link to a beginner's guide if you need to brush up on installing from source code.
Okay.
It's http://mule.vornos.linux, beginners-installing from source. But really, you should be okay with at least the basics. Copying files, seeing what's in a directory, moving between directories, all that, using the command line.
So we need to have those command line skills down pat before we even get started.
Right. Those are like the basic building blocks we're going to be using throughout.
Okay, so our command line kung fu is strong.
Right.
And we're ready to dive in. The first big thing we need to tackle is this thing called the tool chain. I gotta admit, this one has me a bit stumped.
Okay.
It's like we're building a tiny Linux system inside our current system. Isn't that a bit like, I don't know, using a hammer to build a hammer?
You know what? That's a really good way to put it.
Okay.
Because you absolutely need tools to build tools.
Yeah.
If you think about like a carpenter trying to build a house, they can't do it without, their saw, hammer, screwdriver, the whole set.
Yeah, right.
So in the same way, to build a Linux system from scratch,
Mhm.
we need these specialized software tools,
Mhm.
compilers, assemblers, linkers, and that kind of thing.
Okay.
And that's what makes up the tool chain.
So it's kind of like setting up our workshop, making sure we've got all the right equipment to handle the raw code.
Yeah.
So what are the key players in this toolchain lineup? What are they actually doing?
Okay, so let's start with Benoodles. This is a package. And what it's all about is handling object files,
Right.
which are kind of the raw ingredients, if you will, of a program.
Okay.
And it includes this thing called an assembler, which takes human-readable code
Okay.
and turns it into the language that computers actually understand, the machine language.
Right.
And then there's a linker, which takes those object files, those raw ingredients, and sticks them together to create a program that can actually run.
So Benoodles is like getting our workshop set up, making sure we can even work with the code at that level.
Exactly. It's like, making sure your workbench is sturdy and you've got all your tools organized
Right.
before you start building.
Okay. What comes after Benoodles?
Right. So next up is GCC, which stands for the GNU Compiler Collection. And this is where things get really interesting.
Okay.
Because this is where the code we write, those instructions, actually get transformed into something the computer can run.
So GCC is the one that takes our human instructions and translates them into computer speak.
Yeah, precisely.
Gotcha. And finally, there's this thing called glib, the GNUC library. What's that all about?
Okay, so think of glib as this giant library of pre-written code.
Okay.
All these common functions
Yeah.
that are already done for us.
Okay.
It handles stuff like memory management, how the computer uses its memory, input-output, like, how information comes in and goes out.
Right.
And it even does basic math for us. So essentially, it's the glue that holds so many Linux programs together.
So it's like the foundation that a lot of other programs are built on top of.
Well, yeah, exactly. Like the framework of the house.
Okay. So we're building these essential tools within our existing system using its own tools,
Right.
and then those new tools are going to be used to build the final LFS system.
That's it.
It is a bit of a mind bender. It's like, I don't know, those Russian nesting dolls, one inside the other.
Yeah.
And here's what's really blowing my mind. We're using a compiler to build a more advanced compiler.
Yeah.
How does that even work? It's like, which came first, the chicken or the egg?
Well, it's a clever trick, right?
Yeah.
LFS starts by building a basic compiler, kind of like a bare bones model, just enough to get things going.
Okay.
Then they use that compiler
Right.
to build the more sophisticated one.
Oh, so it's like bootstrapping itself, like pulling itself up by its own bootstrap.
Exactly. Ingenious, isn't it?
Definitely.
Yeah.
And the guide emphasizes the importance of doing these sanity checks after building each tool. So it's like making sure your hammer actually works before you start hammering nails.
Absolutely.
It's like, why would you continue if you know it's broken?
Well, imagine getting halfway through building that house and then you realize your saw is blunt.
Yeah, exactly.
It's much better to catch those issues early on, saves a lot of headaches down the road.
Okay, so we've got our tool chain all built. Everything checks out.
Right.
What's the next step on this LFS adventure?
Well, next, we need to create a space for our LFS system to live. So, time to make the LFS partition. Think of it like, prepping the ground before you start building a house.
So it's like laying the foundation.
Yep.
Okay. So we're essentially carving out a piece of our hard drive specifically for LFS. Why is a separate partition so important? Can't we just install it alongside everything else?
Okay, so a separate partition, it gives you a few advantages. First, it lets LFS and your, regular operating system live together peacefully.
Okay.
They won't step on each other's toes. And second, it's like starting with a clean slate.
Right.
There's less risk of conflicts with existing files.
Yeah.
And, potentially messing things up.
So it's like having a dedicated workspace where we can build this LFS house without worrying about accidentally demolishing something else.
Yeah. All about keeping things nice and tidy.
Right. Organization is key.
Oh, yeah.
Okay, so how do we actually create this LFS partition? What are our options?
Okay, so there are a couple of tools you can use. There's fdisk, which is, a command line tool. It gives you very precise control over your partitions. Kind of like using, a set of very fine drafting tools to mark out the space on your hard drive.
Okay.
Then there's gparted, which is more user-friendly. It's got a graphical interface, so it's a bit easier to use.
So that's kind of like choosing between like a manual screwdriver and a power drill.
Yeah, exactly.
They both get the job done. It's just a matter of what you're more comfortable with.
Yeah. One might be a bit easier to handle depending on, your experience level.
Right. Options are good. Now, I'm curious about the partition itself. Like, how big does it need to be? What kind of file system should we use? Are we talking about a mansion or a tiny house here?
So, for the file system, LFS assumes we're going to use XT4, which is, it's pretty standard, very reliable for the main partition, the root partition.
Yeah.
But you do have some flexibility. You could use other file systems, like XT2 or XT3, especially for specific partitions, like the boot partition.
So there's room for personalization even at this stage.
Yeah, definitely. What about size? Well, you'd be surprised how small a functional LFS system can actually be. But generally, a larger partition is better.
Right.
Gives you more space to play around, install extra software later on, and it just gives you more breathing room.
So it's like choosing a plot of land for your house you want to make sure you have enough space for, like a garden or an extension later on.
Yeah. Exactly that.
Okay. You mentioned something called a swap partition earlier. What's that all about?
Right. So swap, it's basically like extra memory for your computer.
All right.
Your computer has RAM.
Right.
Well, if your system starts running low on RAM, it can temporarily move some stuff to the hard drive into the swap space.
Yeah.
And that frees up space in the RAM for the stuff you're actually working on.
So it's like, I don't know, having a spare room in your house for when you have too many guests over.
Yeah, precisely. You might not use it all the time.
Right.
But it's good to have it just in case.
Okay, so any tips on choosing the right size for this swap space?
Well, the old rule of thumb was to make it at least as big as your RAM.
Okay.
But nowadays, computers have so much RAM that you can often get away with a smaller swap, maybe half the size.
Okay.
It really depends on how you're planning to use your system.
All right, so we've got our LFS partition all set up, our foundations laid. What's the next step in building our Linux house from the ground up?
Now we're going to do something called entering the CRUT environment. Imagine like stepping through a portal into this self-contained mini Linux world.
Okay, wait. Crute environment. That sounds like something out of, like, a sci-fi movie.
Yeah, a little bit.
Can you break that down for me? Why do we need this separate universe?
Well, it's all about isolation and control.
Okay.
The Crute environment, it separates our LFS build from the host system,
Okay.
so there are no accidental conflicts,
Right.
and it makes sure we're working with a clean slate. Think of it like a secure sandbox where we can build our LFS house without anything from the outside world interfering.
Okay, so like no unexpected weather delays or, nosy neighbors peeking over the fence.
Exactly, exactly. And also, it gives us complete control. It's like having our own private workshop where we can set up the tools and environment exactly the way we need them.
Gotcha. So no distractions.
Right.
We've got this pristine, isolated environment ready to go. What's the first thing we do inside this Crute universe?
Now we get to lay the bricks. We start installing the core packages that'll form the foundation of our LFS system.
Okay, so it's building time.
It is.
What are some of the key packages we'll be putting in, and what do they do?
Well, get ready for a marathon installation session because we'll be installing a whole bunch, and we'll do them one by one,
Okay.
meticulously following those instructions in the LFS guide.
Okay.
Each package, you got to unpack it, configure it, compile it, and then install it.
So we're really getting our hands dirty with this system building stuff.
Oh, yeah.
What are some of the standout packages in this lineup?
Okay, well, first up is Bash, the born-again shell. This gives us that command line interface that we'll use to actually interact with our LFS system. It's how we'll talk to our new creation.
Ah, the command line.
Right.
The Linux power user's best friend.
Absolutely.
What else have we got?
Then there's Core Utils. This is basically a collection of essential tools for everyday file management. So, commands like key for copying files,
Yep.
L's for listing them out, MV for moving or renaming them, that kind of stuff.
So it's like our toolkit for handling all those basic file operations.
Yeah, exactly. Like the Swiss Army knife of the Linux command line.
Okay. What other tools are we adding to our arsenal here?
We have these three kind of text manipulation wizards.
Sure.
They work together beautifully. Gawk, Sed, and grep. Gawk, it's a powerful scripting language. It lets you manipulate data, create reports.
Yeah.
Kind of like a supercharged spreadsheet, if you will. Sed is a stream editor, perfect for
Yes.
those find and replace jobs, but, on a massive scale.
Right.
And then grep is our, search engine for files. It can find specific patterns in a flash.
So those three are all about handling and transforming text with incredible precision.
Exactly. Very powerful tools.
Oh, okay. Any other essential tools in this initial lineup?
Well, we also have Shadow, which is all about security, managing passwords, controlling who has access to what. It's the guardian of our newly built Linux kingdom, making sure everything's locked down tight.
Security is definitely important.
Oh, yeah, absolutely.
So we're installing all these packages, following the guide like it's gospel,
Right.
double checking everything as we go. It's like building a really complex Lego set,
Yeah.
making sure every brick is in its right place.
It really is.
Yeah.
And the guide is incredibly detailed.
Right.
It's like having an expert standing right beside you, pointing out, potential pitfalls, offering tips along the way.
It's amazing how much work went into creating this LFS guide. From your experience, what are some of the most interesting things you've learned from working with these packages?
Well, one of the fascinating things about LFS is that you really understand why these specific packages are chosen,
Right.
why these and not others. It comes down to making a minimal system,
Okay.
but one that actually works.
Yeah.
A strong foundation to build on.
So stripping away the unnecessary stuff.
Yeah,
And
exactly.
just focusing on the core essentials.
Right. It's like, choosing only the most essential items for a survival kit.
Right.
Each thing has to earn its place.
Okay, I like that analogy. Any personal stories from your own LFS adventures that might shed some light on this whole process?
Yeah, I remember one time I spent hours troubleshooting a package that just would not compile.
Oh, no.
I was, reading through error messages, searching online forums, trying everything I could think of, and it turned out to be this tiny missing dependency,
Okay.
like a small library that the package needed.
Right.
It just wasn't there.
Wow.
And that was a good reminder that, even the smallest detail can make or break the whole build.
It sounds like it takes a lot of patience and, problem-solving skills.
Oh, absolutely.
And I imagine there's a lot of flexibility. You can customize things as you go.
Oh, yeah, definitely. The guide, it gives you a solid base,
Okay.
but it also encourages you to, think critically about the choices you make,
Right.
why you might choose one package over another. You can tailor the system to your specific needs.
Yeah.
Make it truly your own.
So we're not just blindly following instructions, we're learning to make informed decisions about our system,
Exactly.
understanding the why behind the what,
Yeah,
which, that's really cool.
it is. And speaking of understanding the why,
Hmm.
we're coming up on a big moment in this whole LFS build. It's time to install the Linux kernel.
Okay, the kernel, the brain, the heart,
Yeah,
the soul, the operating system.
exactly.
I'm all ears. Tell me everything about the kernel's role and what's involved in getting it set up.
Okay, so the kernel,
Mhm.
its job is to manage the system's resources, talk to the hardware, and provide a platform for all the applications to run on. Think of it like, the conductor of an orchestra,
Okay.
making sure all the instruments play together nicely.
It's the ultimate multitasker, keeping everything running smoothly behind the scenes.
Exactly.
What are the key steps in configuring and compiling this crucial component?
Well, first, we got to choose the right version
Right.
for our hardware and the features we want. There are tons of different kernel versions out there
Okay.
constantly being updated. So we need to consider, things like, is it compatible with our hardware? Does it have the latest security updates? Any specific features we need?
Okay, so it's about choosing the right engine for our car.
Exactly.
One that's powerful and reliable, but also fits our needs.
Yeah, exactly.
Okay, so we've made this big decision.
Right.
We've got our kernel version.
Right.
What's next?
Now comes the fun part.
Hmm.
We get to configure the kernel using a command called make menu config. This brings up like a menu-driven interface where we can tweak hundreds of options.
Wow.
Imagine having this massive control panel
Right.
where you can fine-tune every little aspect of your computer's brain.
That sounds incredibly exciting and also potentially overwhelming.
It is.
So what kind of things are we configuring here?
Everything. Hardware support, networking options, security features, the whole shebang. We can, enable or disable drivers, choose our file system,
Right.
even tweak performance settings. It's like having a whole toolbox
Yeah.
of specialized screwdrivers and wrenches
Right.
for fine-tuning every part of our operating system.
It's amazing to think that we have that much control over the very heart of the OS.
Yeah.
I'm starting to understand why this LFS thing is considered such a powerful learning experience.
Oh, yeah, absolutely is.
You're really getting down into the nuts and bolts of how it all works.
Exactly. And one of the coolest things about the kernel is this concept of kernel modules.
Kernel modules. Okay, I'm intrigued. Tell me more.
Okay, so kernel modules are like little plugins for the kernel.
Okay.
They're these small chunks of code that you can load or unload as you need them
Okay.
without having to rebuild the entire kernel.
So it's like adding or removing functionality without having to take the whole thing apart and put it back together again.
Yeah, exactly. It's very efficient.
So we can kind of customize the kernel on the fly, adding or removing features as needed.
Yeah.
Very cool. Okay, so we've got our kernel configured.
Right.
I'm assuming we compile it at some point.
Yes.
And then what's the next step in this LFS journey?
Okay, so now for the final step, at least for now, it's time to install a bootloader.
A bootloader. Okay, what exactly is that and why is it so important?
Okay, so the bootloader is the bridge between your hardware
Yeah.
and your operating system. It's this tiny program that actually loads the OS when your computer starts up. Without it, your system would be lost, just staring at the hard drive, not knowing what to do.
So the bootloader is I don't know, the ignition key that starts up our Linux engine.
Yeah, exactly.
Okay. What are some popular bootloader options? How do we choose the right one for our LFS system?
Well, one that's very widely used is GRUB, the Grand Unified Bootloader. It's super versatile, supports booting from all sorts of devices, even multiple operating systems. Then there's ILO, the Linux loader. It's known for being really simple and fast.
So a choice between versatility and speed.
Yeah.
How do we go about installing and configuring this bootloader?
So the install process, it involves copying the bootloader files to the right spot on your hard drive,
Okay.
and then configuring it to load our shiny new LFS kernel. We're just making sure the computer knows where to find everything it needs.
Okay, I think I'm getting the big picture here. But what's actually happening behind the scenes when we turn on the computer? How does the bootloader work its magic?
Well, when you hit that power button,
Right.
the first thing that happens is your computer's BIOS or UE5 firmware kicks in. Those are like tiny operating systems built into your hardware.
Right. We've all heard of the BIOS.
Right.
But what's UEFI?
So UE5 stands for Unified Extensible Firmware Interface.
Okay.
And it's basically a modern replacement for the traditional BIOS. Think of it like, a souped-up BIOS.
Right.
It boots faster and it can handle larger hard drives.
So it's like a newer, fancier way to get the computer started.
Yeah, yeah,
So,
exactly.
okay, so then what happens?
Okay, so the BIOS,
Mm.
or UEFI, it looks for a bootloader on your hard drive. And this is where things get interesting. The bootloader relies on something called the Master Boot Record, or MBR.
Okay, I remember that from my computer science classes.
Right.
What is the master boot record?
Okay, so the MBR, it's a tiny section at the very beginning of your hard drive. Imagine like a table of contents for your hard drive.
Okay.
It tells the computer where each partition is,
Right.
and most importantly, where to find the bootloader itself.
So it's like a roadmap for the computer,
Exactly.
guiding it to all the important files it needs to get started.
Yeah, exactly.
Yeah.
And the bootloader needs to be installed in this MBR so it can be found and launched when the computer starts.
Wow, there's a lot going on even before the operating system loads.
Oh, there is. It's a whole symphony of activity happening in
Mm.
those first few seconds.
And here's another question. You mentioned that bootloaders can be configured to boot multiple operating systems.
Yes.
So we could actually have our custom-built LFS system alongside our existing operating system
Exactly.
and choose which one to boot into at startup.
You got it. It's called dual boot setup.
Ah.
Gives you the best of both worlds.
Okay, so we've installed the Linux kernel, the heart of our OS, and a bootloader, the key that starts the engine. Are we done building our LFS house?
We've laid the foundation, built the walls, put on the roof, but we're not quite finished yet.
Okay.
We still need to make sure everything's working properly. You know, configure the bootloader, set up the network,
Yeah.
get the logging working, create some user accounts, all that good stuff.
So it's time for the finishing touches, making sure everything's just right.
Exactly.
Yeah.
We want to make sure our LFS system is stable, secure, and personalized to our liking.
I'm excited to see our fully functional LFS system in action. It's been an amazing journey so far.
It
And
has.
a real testament to the power of open source, and the LFS community.
Absolutely.
Yeah.
And you know what? This is just the beginning. This LFS system, it's a solid foundation.
Right.
You can build on it, customize it to your heart's content.
So it's like we've moved into our new house.
Right.
And now it's time to decorate, furnish it, really make it our own.
Yeah, exactly.
What are some things you would recommend exploring, for people who want to take their LFS system even further?
Well, there's this project called Beyond Linux from Scratch,
Yeah.
BLFS for short, and it picks up right where LFS leaves off. It
Right.
walks you through installing a whole range of software packages, things like desktop environments, graphical applications, developer tools.
So it's like an interior design guide for our LFS house, helping us furnish it with all the amenities and comforts we want.
Exactly. It's a great way to turn your basic LFS system into, a full-fledged desktop or server.
Awesome. Well, I think it's safe to say our deep dive into LFS has been a huge success. We've learned a ton about how Linux works, and we've experienced the thrill of building something this complex
Yeah.
from scratch.
And what's really amazing is that the stuff we've learned along the way, it's not just about LFS.
Right.
These principles of compiling software, configuring systems, managing packages, they're relevant to so many areas of computing.
So we're not just building a system, we're building a foundation of knowledge that we can apply to all sorts of things.
Exactly. And that's the beauty of the deep dive,
Yeah.
right? We're not just skimming the surface, we're going deep, really getting to the core of how things work. So we've laid a solid foundation for our LFS system.
Right, the foundation's there.
Yeah, and we've started to furnish our Linux house, so to speak, with those essential tools.
Okay, so we're moving from construction to interior design now.
Yeah, exactly. And now what gets really interesting is
Okay.
the level of choice we have.
Right.
Because the LFS guide, it's really more like a framework.
Okay.
It's up to us to decide how we want to configure and customize our system. It's like we've built the house, but now we get to decorate it,
Yeah.
choose the furniture, really make it our own.
So we're moving from construction into that personal touch, that interior design phase.
Exactly.
What are some of the first things we need to think about as we, start personalizing our LFS system?
One of the key decisions is how we're going to handle package management.
Wait a minute, didn't we already deal with packages when we built the tool chain?
That's true. But the tool chain, those were the essential tools we needed just to build the system itself.
Right.
Package management is about, how we handle software after the base LFS system is up and running. It's
Okay.
about, installing new software, removing stuff, updating things, and generally keeping everything organized. It's like once you move into your new house,
Right.
you got to decide how you're going to arrange all your furniture, books, belongings.
Right. Yeah. So it's all about keeping order within our Linux house
Exactly.
and making sure all the software is in the right place and working together smoothly.
Precise.
So what are our options for setting up this package management system?
Well, the LFS guide actually presents a few different approaches, each with its own pros and cons.
Okay.
But what's interesting is they don't actually recommend one specific system.
Hmm. That is interesting.
Yeah.
Why do you think they avoid making a recommendation? Is there a downside to picking one over the other?
Well, I think it's partly that and partly about giving users maximum flexibility. Different approaches might work better for different people, depending on their needs. For example, one approach is to just install everything into the standard system directories. Like osverbin for executables, oserlib for libraries.
So it's like, having one big shared closet for all your clothes.
Right. Simple, but it can get messy pretty quick.
Yeah, exactly.
Another approach is to install packages into separate directories.
Okay.
So you might have like a user APKG directory
Okay.
with subdirectories for each package.
So that's like having separate closets for
Yeah.
different types of clothing.
Exactly. More organized, but maybe a bit more work to manage.
Right, right.
And then there are even more, sophisticated approaches
Yeah.
that involve like timestamping files
Okay.
or using symbolic links to keep track of everything.
Okay.
The guide goes into detail about each method so you can understand the trade-offs and choose what's best for you.
It's like having blueprints for different closet organization systems.
Yeah, exactly.
We can choose the one that fits our organizational style.
Exactly.
Okay, so we've got package management sorted out.
Right.
What's next on the LFS to-do list?
Now we need to create some essential directories and files.
Okay.
It's like framing the rooms in our Linux house,
Okay.
laying out the basic structure before we start bringing in the furniture.
All right, so what are some of these like essential directories?
Okay, well, we'll need directories like dev for device files, proc for process information, sys for system information, run for temporary runtime files. These are like the utility rooms, the wiring, the plumbing of our LFS house.
So we're setting up the framework for our LFS system to interact with the hardware, manage processes, keep track of all that vital information.
Exactly. All that essential infrastructure
Yeah.
to keep everything running smoothly.
It's all starting to come together. What about essential files? Are there specific files we need to create at this stage?
Absolutely.
Mhm.
We'll need to create files like etcetera for user accounts, etcetera group for group information. These files, they're crucial for managing user access and permissions.
Huh.
It's like setting the locks on the doors, defining who has access to which rooms in our house.
So we're basically setting up the security system for our Linux house,
Exactly.
defining who has the keys to what.
Right.
And I imagine we'll also be creating those symbolic links.
Yes. Symbolic links, remember, they're like shortcuts
Right.
that point to other files or directories.
Right.
They help keep our system organized and make sure everything's in the right place. Think of them like, convenient pathways between different rooms.
Okay.
So you can easily get around the house.
I love those real-world analogies that make it so much easier to picture what's happening.
Yeah,
So we're creating this well-structured, well-organized system where everything's easy to find and access.
exactly. Everything in its right place.
Okay, so we've got all those directories, files, symbolic links in place. What's next?
Now it's time to install the Linux API headers.
Linux API headers. Okay, I'm going to need a bit more explanation on that one.
Okay.
What are they and why are they so important?
So the Linux API headers, they're like a communication protocol
Okay.
between the system's C library, that's glibc in our case,
Right.
and the Linux kernel.
Okay.
They define the functions and structures that the C library uses to talk to the kernel.
So it's like establishing a common language between the C library and the kernel.
Precisely.
Yeah.
Like having a translator so two people who speak different languages can communicate.
Right, yeah, it's all about clear communication.
Yeah.
How do we actually install these Linux API headers? Are they, like, included with the kernel source code?
They are. They actually come from the kernel source code,
Okay.
but they need to be extracted and cleaned up a bit. We've got to remove any code that's not relevant to the user space.
Yep.
It's like taking a blueprint for a building
Okay.
and removing all the sections that only the construction crew needs to see.
Yeah. Leaving a cleaner version for the people who are actually going to live there.
So we're essentially sanitizing the kernel code,
Right.
making it suitable for use by the C library.
Exactly.
Gotcha. What comes after we've installed these Linux API headers?
Now we get to install something I'm sure you'll appreciate. Man pages.
Man pages. Those have saved my bacon countless times when I'm trying to figure out how to use a command.
Right.
Why do we need to install them so early on in the LFS build process?
Well, man pages, short for manual pages, the documentation for all those Linux commands and utilities. They're like a built-in encyclopedia for our LFS system,
Right.
giving you detailed info about how to use each command, its syntax, options, even examples.
Mhm.
Having them installed early means we can use them as we keep building and exploring our system.
It's like having a comprehensive instruction manual for our new house
Exactly.
before we start filling it with appliances and furniture. Right. And as we install more and more packages, those man pages are going to become even more valuable, helping us understand how everything works
Yeah.
and how to use all these new tools we have.
Okay, we've got those Linux API headers, our communication protocol, and the man pages, our trusty guidebook. What's next?
Now we're going to tackle one of the most complex and crucial packages in the entire LFS build, glib, the GNU-C library.
Lipkist. We met that back when we were building the toolchain, but I have a feeling this is going to be a bit more involved than just compiling it again.
You're right. This time we're installing glib as a core part of our LFS system. It provides those essential functions and system calls that pretty much every Linux program relies on.
So it's like the bedrock, the
Yeah.
foundation that everything else is built on top of.
Precisely. Without glib, most Linux programs just wouldn't work. It handles everything.
Mm.
Memory management, string manipulation, input-output operations, system calls. It's a real workhorse.
Wow, glib sounds like a real heavy hitter. What are some of the key things we need to think about when installing it in our LFS environment?
Well, one of the most important things is making sure we're using the right compiler, the right binary tools, the right kernel headers. Glib can be a bit picky about its environment. It's like making sure you have all the right ingredients and the oven's at the right temperature before you start baking a cake.
Right, we don't want our glib soufflé to fall flat.
Exactly.
So the LFS guide will walk us through the configuration process, making sure everything's set up correctly.
Right.
What are some of the things we'll be configuring specifically to tailor glib to our LFS system?
We'll be configuring things like the dynamic loader,
Okay.
which is responsible for loading shared libraries at runtime.
Shared libraries. Refresh my memory. What are those again?
Right, so shared libraries are like collections of pre-written code
Okay.
that multiple programs can use at the same time.
Right?
It's a way to avoid code duplication and make programs smaller and more efficient.
Yeah.
So instead of each program having its own copy of the same code,
Mm.
they can all share it. It's like, borrowing books from a library instead of everyone owning their own copy.
Right, that makes sense.
Yeah.
So we're configuring the dynamic loader to handle these shared libraries. What else do we need to configure?
We also need to set up locales, which determine things like language, character encoding, and date and time formatting.
So we're making our LFS system multilingual and culturally aware.
Exactly. We're customizing glib to fit our specific needs. Make
Wow.
sure it behaves just the way we want it to.
It's like personalizing our house,
Right.
choosing what language we want on the labels, the format for the clocks,
Exactly.
even the units of measurement for our tools.
Precisely. And once glib is installed, we need to update our tool chain. So we have to recompile some of the tools we built earlier,
Mhm.
like bnoodles and GCC, to make sure they're compatible with our new glib.
So making sure everything's playing nicely together.
Exactly. It's like making sure all the tools in our workshop are compatible with the new electrical system we just installed.
Okay, so glib is in place. Our tool chain's updated. What happens next?
Now we can really start filling up our Linux house.
Okay.
It's time to install a whole bunch of other essential packages that depend on glib.
All right, time to go software shopping.
It is.
What are some of the key packages we'll be installing after glib?
Oh, there's a whole bunch, each with its own special purpose. We've got packages like zlib for compressing files, file for determining file types, readline for making our command line experience smoother, and M4, that macro processor we talked about earlier, for automating tasks during the build process.
So we're adding utilities for compression, file identification, command line enhancements, and build automation.
Yeah.
What else is on the shopping list?
We'll also install BC for, doing complex calculations, GMP, MPFR, and MPC for handling really big numbers with incredible precision, Overflow for working with those extended file attributes, ADDLCulf for managing access control lists, and our old friend Shadow for managing security and user accounts.
Wow, we're really stocking up.
We are.
It sounds like we're equipping our LFS system with a whole range of capabilities.
Exactly. We're adding all these essential utilities and libraries that will let our LFS system perform all sorts of tasks and run even more complex software.
Okay, so we've got our foundation, our tools are ready, and we're starting to furnish our LFS house with some serious software.
We are.
I can't wait to see where this journey takes us next.
So we built this solid foundation for our LFS system, furnished it with essential tools, and now it's time to make sure it can talk to the world, connect to the network.
Okay, let's get our LFS system online. What's the key player in making that happen?
The star of the networking show is iProot2. Yeah, it's a collection of utilities that give us total control over network interfaces, routing tables, pretty much all of the networking stuff.
Okay, so iProot2 is like our network command center.
Exactly.
We can use it to configure everything and monitor how our LFS system connects to the network.
You got it. With iProot2, we can assign IP addresses, set up routing rules, even troubleshoot any network problems that pop up. It's like having a toolbox full of specialized tools just for networking.
So it's giving us a deep dive into how networking actually works.
It is. It is.
Okay, so we've got iProot2 installed. What's next?
Next up is KBD, a package that makes sure our LFS system gets along well with our keyboards.
So we're making sure our keys are mapped correctly?
Yeah, and that we can use different keyboard layouts.
Oh.
We want to make sure our LFS system is comfortable and efficient for everyone,
Right.
no matter what language they speak or what kind of keyboard they use.
Okay, so it's all about accessibility and making sure everyone feels welcome in our LFS world.
Exactly. KBD gives us that fine-grained control over things like, how fast the keys repeat when you hold them down, language-specific layouts, even special characters. It's like having a custom keyboard designer on call.
I love that attention to detail. Okay, so our keyboard setup's sorted. What's next on the list?
Now, we're going to install a program that I'm sure a lot of Linux users are already familiar with. Less.
Less. Less is more.
Exactly.
I use Less all the time for viewing big text files. It's so much better than opening them in a huge text editor.
Right.
Why is it considered such a fundamental part of the LFS system?
Well, Less is great for viewing those large text files one screen at a time. You can scroll through, search for specific text, jump to specific lines. Super handy for things like log files, configuration files, even code.
It's like having a high-powered magnifying glass for text files, making it easy to navigate even the most massive documents.
Exactly. And speaking of massive documents, after Less, we'll be installing something that plays a key role in how our LFS system boots up. LFS boot scripts.
LFS boot scripts, what are those and why are they so important?
Okay, think of boot scripts as the stage crew, setting up everything before a show.
Okay.
They're responsible for starting essential services, loading kernel modules, configuring network interfaces, all that stuff, before our LFS system takes the stage.
So they're working behind the scenes
Yeah.
to make sure everything's ready to go and the system boots up.
Right, exactly.
Okay, so our boot scripts are in place.
Right.
What's next?
Next, we install ManDB.
ManDB. Okay.
This one helps manage those all-important man pages we installed earlier.
Right. We already have the man pages.
Yeah.
So why do we need a separate package to manage them?
So ManDB provides a set of tools for searching, indexing, and formatting man pages. It makes sure they're organized and easy to search,
Okay.
so we can quickly find what we need.
So it's like having a librarian for our man pages.
Yeah, a very organized librarian.
Right, making sure everything's easy to find.
Exactly.
Okay, so our documentation's all squared away.
Yeah.
What's next on the agenda?
Now we get to install a real powerhouse for manipulating text.
Yeah, the stream editor.
The stream editor. I have a feeling this time we're installing the full version, not just the one we use for the toolchain.
That's right. Now SED is here to stay, ready to help us with all sorts of text and file manipulation tasks.
Okay, I'm ready to unleash the full power of SED. Remind me again what makes it so good at manipulating text.
So SED is all about non-interactive text editing. It's really good at things like, searching and replacing text, deleting specific lines, inserting new text into a file. Imagine doing all that across, hundreds of files with just one command that's SED.
Wow, SED is like a text editing ninja,
Yeah.
quietly and efficiently transforming our files with just a few keystrokes.
That's a great way to put it.
Okay, so we've got our text manipulating master installed. What's next?
Next is SMISC.
Dismiss.
Yeah, a collection of utilities that give us a peek into those running processes.
Okay, so we already have SMISC for monitoring processes.
Right.
What does SMISC bring to the table? So SMISC stands for Process Miscellaneous,
Okay.
and it includes commands like stree, which shows you all the running processes in a tree-like structure.
Okay.
You can see how they're related to each other.
Right.
And then there's fuser, which tells you which processes are using a particular file or directory.
So it's like we're getting X-ray vision into our system's processes. Seeing what's running, how it's all connected, what resources each process is using.
It's a must-have for anyone who wants to understand how their LFS system is ticking.
Okay, so SMISC is our process monitoring tool, giving us that behind-the-scenes look.
Right.
What comes after that?
Next up, we install IANA, etc. This one provides data for all those network services and protocols.
IONA, etc. What does that even mean?
Okay, so IANA, etc. is like a phone book for network services.
Wait.
It maps those service names to port numbers and protocol names to protocol numbers.
Oh, okay.
It makes sure our LFS system can actually talk to other systems on the network.
So making sure our LFS system speaks the same language as everyone else on the internet.
Exactly.
Crucial for all that online stuff. What's next?
All right, now for a package, that's a real workhorse in a lot of software tools. Flex. This one's all about lexical analysis.
Lexical analysis. Okay, that sounds a bit technical. What is that?
So think of lexical analysis as like breaking down a stream of characters into meaningful chunks.
Okay.
Words, numbers, symbols.
Right.
It's how compilers, interpreters, and other programs that process text actually understand what we're telling them.
So Flex is like a language expert
Yes.
helping our LFS system understand the structure and meaning of text.
Precisely. It's a key component in a lot of software tools,
Okay.
especially ones that process text, like compilers, text editors, things like that.
So Flex is our language guru, making sure our LFS system is fluent in, the language of text processing. What's next?
Now, for a tool that many Linux users consider a trusty friend, tar. This one's all about creating and working with archive files.
tar, the classic archiving utility.
That's it.
I've used tar countless times for backing up files and, sharing software.
Right.
What makes it so indispensable in the LFS world?
Well, tar lets us bundle up multiple files and directories into a single archive file. Super convenient for backing up data, distributing software, even just moving a bunch of files between systems.
So it's like having a digital packing crate,
Yeah.
letting us organize and move our files around easily.
Exactly.
Okay, so after tar, what do we have?
Now it's time for Time, a package that provides a set of utilities for working with, well, time.
Time. Why do we need a special package for that?
The Time package gives us commands like date, which shows the current date and time,
Yep.
and MAGOL, which shows a calendar. They seem simple, but accurate timekeeping is actually really important for lots of system functions. Things like scheduling tasks or logging events.
Okay, so we're making sure our LFS system is punctual and knows what time it is.
Exactly. We don't want it to be late for any important appointments.
Right. What's next on the list?
Next, we'll install TextInfo, a documentation system that's widely used for creating online documentation.
TextInfo. Okay, what kind of documentation does it create?
TextInfo is great for making well-structured, searchable documentation that you can access online.
Okay.
A lot of software packages, especially from the GNU project, they use TextInfo for their manuals and guides. It's a great resource for anyone who wants to really dig deep into our LFS system.
So it's like providing a comprehensive set of instructions,
Yeah.
making it easier to learn about our LFS system and explore its capabilities.
Exactly. After TextInfo, we install a text editor that a lot of developers love, Vim.
Vim.
Known for its efficiency and flexibility, but also that steep learning curve.
Oh, yeah.
What makes Vim so popular,
Yeah.
and why is it an essential part of the LFS world?
Vim is a very powerful text editor,
Okay.
and it's super popular among programmers and system administrators.
Okay.
It's incredibly efficient. You can do really complex editing with just a few keystrokes, but it does take a bit of effort to learn. So it's like a high-performance sports car for text editing.
Yeah.
It takes some skill to handle, but once you master it, you can really fly.
That's a great analogy.
Yeah.
And once we've installed Vim, we add another tool for system monitoring to our toolkit, proxying.
Propsing. We already have SMISC for monitoring processes.
Yeah.
What's different about this one?
Proxying, it stands for process status, and it gives us some extra utilities for monitoring system resources. Things like top, which shows a live list of running processes,
Right.
how much resources they're using, and free, which tells us how much memory is being used.
So it's like having a dashboard for our system, showing us all those vital signs in real time.
Exactly. It's great for keeping a close eye on your system's performance.
Okay, so proxying is our system monitoring command center.
Right.
What comes after that?
Now for util Linux.
Util Linux.
It's a collection of utilities for managing file systems, partitions, and other system tasks.
Sounds like a mixed bag of goodies.
It is. You've got commands like fdisk for partitioning hard drives, mount for mounting file systems, dmesg for viewing kernel messages. It's like a treasure chest of tools for building, maintaining, and troubleshooting our LFS system.
So it's a Swiss Army knife for system administrators, Packed with all sorts of essential tools.
You got it.
Okay, what's next on our list?
Next up, we install E2F sprogs. This one provides utilities for working with ext file systems.
Okay.
Like X24, which is what we're using for our LFS system.
Right, so we're making sure we have the right tools to manage our file system effectively.
Exactly. E2S Sprogs gives us the power to create, modify, and repair those X file systems. We can also use it to work with extended file attributes, those extra bits of information we can attach to files.
So it's like a specialized toolkit for working with the very foundation of our LFS house.
Yeah, precisely.
Okay, so what comes after we've got our file system tools all set up?
Now for the heart of how our system starts up and shuts down, Sysfinit.
Sysfinit. Okay, what's so special about this one?
Sysfinit is what we call an inner system. Okay.
It's responsible for starting and stopping services, managing run levels, and doing all sorts of other system initialization tasks during the boot process.
So it's like the conductor of an orchestra, making sure all the different services and processes start up and shut down in the right order.
Exactly. A very organized conductor.
Keeping everything running smoothly.
And with Sysfinit in place, we've actually reached a major milestone.
Okay.
We've installed all the essential packages for a basic functional Linux system.
Wow. We actually built a whole operating system from scratch.
It did.
It's been quite a journey, but incredibly rewarding.
Oh, yeah.
But I'm guessing our work isn't quite finished yet.
You're right. We've built the house, but now we need to make sure everything's working as it should.
Right.
We need to configure the bootloader, set up our network, make sure the logging's working, create some user accounts, and take care of some basic security stuff.
So it's like going through that final checklist before we move into our new house,
Making sure all the lights work, the doors lock, that we have a welcome mat out front.
Exactly. We want to make sure our LFS system is stable, secure, and ready for us to move in.
I'm excited to see our fully functional LFS system come to life. It's been a real testament to the power of open source, and the dedication of the LFS community.
It really has.
So what would you recommend for people who want to, take their LFS system to the next level?
Well, there's this project called Beyond Linux from Scratch, or BLFS.
Okay, BLFS.
It picks up where LFS leaves off.
Okay.
It walks you through installing a whole bunch of other software packages, desktop environments, graphical applications, developer tools, that kind of stuff.
So it's like we've built the house, and now BLFS is the interior design guide, helping us furnish it with all the bells and whistles.
Exactly. A great way to turn your basic LFS system into a fully featured desktop or server.
Awesome. Well, I think our deep dive into LFS has been a resounding success. We've learned so much about how Linux works, and we've experienced the thrill of building something this complex and powerful from scratch.
And the amazing thing is that what we've learned here, it goes beyond LFS.
Right.
These principles of SAC recompilation, system configuration, package management, they're relevant to so many areas of computing.
So we're not just building a system, we're building a foundation of knowledge and skills
Absolutely.
that we can use in our future explorations of technology.
That's the beauty of the deep dive. We're not just skimming the surface, we're going deep, empowering ourselves with a true understanding of how things work.
And on that note, we've reached the end of our LFS adventure. A huge thank you to our expert for guiding us on this journey and sharing their insights. And to our listeners, keep exploring, keep learning, and never stop diving deep.